Hey guys, happy Tuesday. I wanted to get on here and give you a quick video of an overview of our math packet this week. There's a lot of new stuff in there once again, and then also some spiral review of things that we've already learned. So, the new stuff is the part about combining and separating shapes, and then there is a section on understanding area and perimeter, and also a small section on congruent and non-congruent shapes. So I want to jump in and kind of go over some of the new content and then just breeze through the part that is the review of the fractions and division. Okay, so the first part of my packet here, we are talking about combining and separating shapes. Okay, so in third grade, we use pattern blocks or shapes to combine together to create new shapes, like these triangles here forming a trapezoid, or we use it when we have shapes and then we kind of chop them up or separate them into other shapes. For example, here, this hexagon, and then separating it into two trapezoids. Okay, so I'm going to focus in on this example right here with the hexagon and trapezoids because that one actually helps me do this example here and then this example here. Okay, so our first one says, how many trapezoids make a hexagon? Well, we know here that we separated a hexagon into two trapezoids, so I'm going to do the opposite of that here, where I have two split up trapezoids. I'm going to combine them into one hexagon. Okay, and then another look at that example is here, where it says, please draw a line to show two trapezoids. So I'm just going to do a vertical line down the middle of this hexagon so that I can create the two trapezoids. Okay, so your first couple pages are really just focused on that, the practicing all the combining and separating. All right. Now I know it's a little bit harder, you're not having the actual shapes to manipulate, but luckily these pages do have a lot of good visuals to help you. Okay, so we have that there. On the back is a little bit of a challenge so that you can fold and cut paper to try to practice making some of these shapes. Okay, and then this page here and the top part here is also continued on combining and separating shapes. So that's your first new content and your practice area there. Okay, under the shapes is where we start some of our spiral review. There we have some multiplication, some division, and then some fractional parts and equivalent fractions. Okay, after that we're going to jump into identifying congruent shapes. Okay, now before I show you those examples, I want to explain to you that congruent and non-congruent. What do those words mean? Well, in order for shapes to be congruent, that means they have to be the same size and the same shape. That's the only way they can be considered congruent, is if they meet those two requirements. Otherwise, they're considered non-congruent shapes. Okay, so I have a little example here. Okay, these pairs of shapes would be what is considered congruent. They're the same shape and they're the same size. Here, however, would be non-examples, examples of shapes that are not congruent. They're either the same shape and they're not the same size, or they're different shapes altogether. Okay, so I want you to think of that when you are trying to determine, is this pair of shapes congruent? You have to think, is it the same size and the same shape? Okay, so if you look at this page of your packet, this part kind of goes over that explanation that I was giving, and then it wants you to try some on your own with these two examples. Okay, one is congruent, one is not congruent, so let's look closely. Okay, let's look closely at this. If you look here, you can tell that these two shapes, okay, they are similar shapes, but they are not the same size. So this pair of shapes would be non-congruent, okay? However, this pair of triangles, okay, they're the same shape and they're the same size. You can see that by, it's got 3 dots going on each side, so they're equal triangles here, so that pair would be congruent. Remember, same size and same shape. So we have this one here, and then for parents, a key on the back to help go through those. All right, now I want to jump into understanding area and perimeter. So area is the amount of surface, okay, surface space that the flat object has, okay? So I want you to think of square units, and I want you to think of like when we are measuring something like the carpet or tile to cover the floor, okay? Measuring those in square units. So I have an example here of how we would determine the area of a set of shapes, okay? So you're going to get these odd looking area models in these little square units, okay? And in order to determine area, we are going to count the number of squares, okay? So here's my shape, and as I go through, I'm going to count each box one by one, okay, until I determine the area is 15 square units, okay? So area is counting the amount of space, the amount of flat space, okay? So if you look in your packet, you have some examples there, okay? And it goes step by step with what I want you to do. So it starts out with an open shape, and then I want you to connect the dots to create those little square boxes so that you can easily count them, okay? So you have 3 examples here. Let's just split those up a little bit, and I'll show you what that looks like when you connect the dots so that you can easily count up those squares, okay? So go ahead on your packet and connect all those dots so that you can easily count them up. For example, now that we've connected the dots, the first one we can tell has an area of 4 square units. 1, 2, 3, 4. You see my example there? Okay. So on this page of the packet and then on the back, you are connecting those dots and counting up those square units, okay? Here you have the shape and you're calculating it. Here's a little bit of the opposite, where it's giving you the total area and it wants you to create a shape that matches that area with that many squares, okay? The next page is those area models continued, okay? And then it is also relating it to multiplication. So when it gives you that area model, that grid like that, I want you to, just as this example says, count the amount of rows, okay, going down, and then count the number of columns, okay? So you will find rows by columns and multiply those, and that will give you your total area. Like this example here, 6 rows times 10 columns equals an area of 60. All right, so there's a couple here to try using that multiplication strategy when you have a full area like grid right there, okay? On the back are some area riddles to try to solve. Now, this is where we're going to switch gears to perimeter, okay? The figures and shapes are going to look pretty similar to area, but you're going to do a different strategy to figure it out. Rather than count the inside of a shape, instead you are going to calculate the distance around the figure, okay? The outside edge. So, this is when you would be measuring like the wallpaper border to go around the room, or if you are making a fence around your yard or your pool, okay? So here I have a figure like this, but instead of counting the squares, okay, I am going to make little tick marks, all right? And I'm going to count all the edges until I find the total. So put it on my clipboard here so you can see. Now instead of counting the inside, I'm going to go around the edges with little tick marks. 1, 2, 3, 4, 5. Really go all around the shape in every edge. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so it's a little bit different than area. Area, you are just counting the squares. Perimeter, you are getting every outside edge, okay? So some squares may have more than one tick mark as you're counting around the edge. So after looking at that perimeter example, that is how you are going to find the perimeter of each of these figures. So make sure as you're going around, you see that outline of the shape, you are going through and getting every little edge. This one is pretty easy looking square, so I'm going to do this shape here, number 2, and do one more practice so that you can be confident in your determining the perimeter. So let's go through and get those edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the perimeter of this figure for number 2 is 12 centimeters. Now, the reason I like to do tick marks is so I can, as I go around and I count, I don't just try to keep a hold of it in my brain. I actually have all the visuals there to make sure that I've gotten every single edge of the figure. All right, so some practice of perimeter there and on the back. Kind of like before with the area, this one is giving you the amount of units and you have to create the shape that has that. Okay, so this might take a little trial and error as you're designing the shape and then making sure it matches up with the perimeter it gave you. Okay, now take what you know for this page, take what you know for area and perimeter, both ways to count, counting the inside squares and counting the outside edges, and combine that for this page. Okay, on the back here we have some matchups. All your figures are over here, okay? And it wants you to determine the area and perimeter of those in order to match them up with the clues here, or the descriptions. Now that we've gone through that, that's all the new stuff. The back final pages are some games related to fractions, adding and subtracting fractions. So remember, when you are adding fractions, the denominator on the bottom stays the same and you only add the numerator. Okay, for example, here if I had, so you can see here, 2/10 plus 5/10, okay? If I have that, my denominator is going to stay the same. I'm going to keep that in tenths, okay? And then just add up the numerator. 2 plus 5, 7. So I have a sum of 7/10, okay? So you can follow the directions on that game. You just need, it looks like, some dice to roll to create your denominator and numerator, okay? And the same approach for subtracting fractions. So in 3rd grade, once again, when we are adding and subtracting fractions, the denominator stays the same. We only change the numerator when we're adding and subtracting. Okay? So you have some fraction bar games there. And then you have a number line here where you can also add the fractions on the number line. Okay? This one, when you're adding them, you can keep going and you're creating your improper fractions or your mixed numbers. And then finally, some game instructions for this division game. Remember, Mr. Nichols went over our multiplication and division strategies in one of his videos, so if you need to kind of jog your memory on how we solve division problems and multiplication problems. You can watch that video. Okay, so some directions there. Well, I know this went pretty quick, but I hope that that helped you understand a little bit better some of the new content so that you can practice that packet on your own at home. Okay, so please watch our other videos if you're having any other difficulties completing some of the packets. I know Brain Pop, if you go through your Clever, has some good videos on some of this content as well. If you want to watch videos on area and perimeter or some of the shapes like congruent and non-congruent, some of those videos will help as well. Okay, well, thanks for joining me, guys, and I will catch you next time.